Okay, so let's get started. We're going to be taking a look at setting up and working with an advanced style nitrous control strategy within our Link G5 and G4X programming. Now, the last tutorial we covered our basic nitrous control strategy. It was a little bit complex. We had a lot of things to set up and configure in the software. We're going to take things a step further now, learning how we can work with a pulse width modulated style control strategy with nitrous. Gives us the ability to vary how much nitrous flow we're bringing into the engine. A lot of opportunities there to stage nitrous based on speed, by gear, based on engine speed, so you can actually control the torque production with the nitrous and ramp it in how you'd like. We're also going to be learning how we can integrate a bottle heater, a bottle opener, and a nitrous pressure sensor, because all of this can be used within the control strategy so that we can have a hands-off approach to actually enabling our nitrous. So we can have an arming switch, we can kick the arming switch on, and then we can allow the system to control everything from the bottle heater to the bottle opening. So we don't even have to get out of the car to make the whole entire system work. Obviously, you have to have all these components installed within your nitrous system, but assuming you do, we can wire it up as we're describing in the tutorial here, and you'll have a hands-off type of approach for your nitrous control system. You're going to be essentially automating everything. It's a really nice way to go about working in nitrous control. I've done this on a few vehicles, and it's always came out really well in terms of the entire control strategy. So let's break this down a little bit so we can understand how this all works. Now, I do want to mention that the Link G5 Voodoo Pro does natively support nitrous control within the software. So if you connect your G5 Voodoo Pro to your software, to your laptop, you're going to notice here under ECU settings, under motorsports, that there is going to be a nitrous control that we can actually start to take a look at here. The G4X does not have this at this point in time, so I'm not sure quite why, but it doesn't really matter. The control strategy we're going to be presenting in this tutorial will apply whether we're going to be for a G4X or a G5. So let's go ahead and minimize that. Now, that could change in the software in the future, but for right now, at the time of filming, that's what I'm noticing. G5 seems to have this nitrous control natively supported, but we can get creative and get around all this, going and using virtual auxes and building the general purpose output blocks. I'll describe how to set this all up. So this, again, is going to be an automated type of system. So before we go into taking a look at the schematic of how everything lays out and describing all the subcomponents in our system, I want to talk just real briefly here about some basics with nitrous control. We talked about this in the last tutorial, but we're just going to quickly run through it in the beginning of this tutorial in case you skipped the basic nitrous tutorial. So first things first, let's talk about the difference between a dry and a wet shot of nitrous. A dry shot of nitrous is when we're spraying just nitrous into the engine. A wet shot of nitrous is when we're going to be spraying both fuel and nitrous at the same time. Now, a dry shot requires you to have the additional fuel flow needed through the port fuel injectors to support how much nitrous you're trying to bring into the engine. When we're doing a wet shot of nitrous, you're going to be jetting there's a nitrous jet and there's the fuel jet. You're going to be jetting the fuel, so it's proportional to the nitrous that you're spraying into the engine. The nitrous manufacturer will give you the fuel jetting sizes that'll be appropriate for the nitrous that you're spraying in, so you'll have to set that up. The dry system is a little more complex because we have to actually account for the fuel to make sure the engine's not going to run lean. With the wet shot, we don't need to worry about that. We just need to set that jet size, and it'll do the rest for us. So all we're going to be doing in terms of programming for the wet shot is going to be just dealing with spark retard when we're spraying the nitrous. If we're doing a dry shot, then we're going to be doing fuel and spark timing. We're actually going to have to be compensating for both. Now, moving on, we're going to see the difference then between a single fogger versus direct port. Single fogger is where we have just a single fogger jet in the intake tube. It's going to have to go through the throttle body, intake manifold, and distribute into each runner. It's fine to use a single fogger for about a 75 shot and below, but if you're going to go higher in nitrous shot, you definitely want to go to a direct port. Direct port is going to make sure that we don't have any distribution problems for the nitrous evenly getting into each cylinder. If you do it through a fogger style jet, you run the risk of the nitrous not being evenly distributed between each cylinder. So you may have a cylinder that gets more or less nitrous. That can be problematic. It can definitely damage a cylinder. So direct port is good if you're going higher than a 75 shot. So anytime I'm going bigger than a 75, I'm going right to direct port. And that's how I'm going to be showing here in this tutorial. We actually have a single fogger, but I would recommend to actually go direct port if you're going to be doing anything larger than the 75. So let's take a look now at what we have for the control system, what we're trying to control here for this particular tutorial. There's a lot of components, a lot of things we need to factor in. So coming up on screen, we're going to find that we have our schematic of the system that we're working with here. So we're going to find that we have our link over there on the right. Then we're going to find we have an arming switch. We have a solid state relay. And that's typically what I use from Holly. And that's going to be part number 15620NOS. That's a great solid state relay. It's about $80. And I use it for a ton of different solid state relay control. It works great for nitrous control. And that's actually originally what it was designed for, but it can even do fuel pump control in some cases. So we see we have a solid state relay. We have a normal 30 or 40 amp relay. We're actually going to have two relays. I don't have it pictured here in this particular schematic, but we actually need to have two relays. One relay here is going to be controlling the bottle heater. Another relay is actually going to be controlling the bottle opener. So this schematic is actually just lacking the additional relay, but we will have to have another output from the link to turn on another relay to turn on the bottle opener to open the bottle up. We also have, in addition to this, we have our nitrous solenoid that's actually compatible to be pulse width modulated, pulsed from the solid state relay. And then we also have a nitrous pressure, bottle pressure. We can see the nitrous pressure transducer is in the nitrous line. So that's going from the bottle to the nitrous solenoid, and then the nitrous solenoid is going to a single nitrous jet here. So this is just showing a dry shot, and it's showing a single fogger option. I'd recommend to do direct because you're probably going to be running 100 shot or larger with this. But just to keep this kind of simplistic in my schematic, I just had that single fogger jet that we're seeing there. So this is assuming dry shot. This is pulse width modulated. And then we have two relays. Again, one relay is not pictured, and we have that arming switch. Let's quickly just talk about the pulse width modulated aspect of this because we haven't talked about that yet. So when we're dealing with nitrous control, we can actually pulse width modulate how much nitrous we're bringing into the engine in a 0 to 100% format. So 0% means that we're not sending any output control to the nitrous control solenoid and no nitrous flows coming into the engine. 100% command it through the link to the solid state relay, then controlling to the nitrous solenoid means that that solenoid's wide open. It's going to deliver maximum pressure and flow to the nitrous jets. Now, whatever you've set your jet size to, that's what you should see then coming into the engine. So if you have a 100 shot, you should see a full 100 shot at 100% duty cycle. If you are at 50% duty cycle, command it from the link to the solid state relay to the solenoid. You should see somewhere between half of that. So it should be somewhere between maybe 40 to 60 shot worth of nitrous flow coming into the engine. So the advantages of working with a pulse width modulated style control is that we can vary how much nitrous we're bringing into the engine, and we can do that based on gear, we can do that based on speed, we can do that based on any kind of programming condition, and it's really, really effective. So let's take a look at this real quick. So let's start to take a look at setting all of these components up within the schematic as we're finding here. I'm actually going to keep it up on screen and we're going to go through things one by one. So the first thing we want to set up here to make this work is our arming switch. The arming switch is a basic on-off toggle switch. One leg of that arming switch is going to go to chassis or battery ground. The other leg is going to come into our link and we're going to ground typically a digital input pin. And this is going to tell the link when the switch is armed that we want to spray nitrous, but then we have a lot of conditions that we want to meet in order for the nitrous to actually spray. So there's a lot more layers into the programming logic to make all this work. But let's talk about how we're going to set this up. So the first thing is setting up our arming switch. Let's go to our digital inputs and let's take a look at setting this up. So if we go and take a step back here to the left, we're going to go into our digital input window. And let's go in here, we have our general purpose input 1. Let's reassign this for our nitrous arming switch. So we're going to go here to the label, and I'm going to go and call this nitrous arming. And then into the source here, we're going to go ahead and set this to our digital input 3. Digital input 3 in my case is set for my switch. That's where I've wired it into. So we see our pull-up resistor is on and the active state is low. I've wired the switch again as I just described. It's going to chassis or battery ground. And then the other leg of the switch is going into digital input 3. So therefore, we need the pull-up resistor on to complete the circuit, and then we need the active state as low. if you were setting up your switch so that you had 12 volt coming into the switch and you were sending 12 volt into digital input 3, your pull-up resistor would be off and then your active state would be high. That's just.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.